Welcome. In this video, we'll continue by demonstrating how to add insect disturbance layers to our existing GCBM project so that it can run in a new simulation. Navigate to sample_data_exercise /layers/raw/disturbances/insects, and this time it includes a series of shapefiles. Often, if a user has a set of disturbance shapefiles, they will contain multiple disturbance types, which is the case with these sample files. In this instance, there are shapefiles per year containing a few different severities of mountain pine beetle. The insect layers in this project are in vector format, and the insect disturbance is the mountain pine beetle, an attribute of severity which can have three possible values, 1, 2, or 3, with 1 being light and 3 being severe, and a disturbance year attribute called year_, have been set up. A substitution table is needed to map the severity values to disturbance types in the archive index database. We'll demonstrate how to do that in the tiler. If you were going to open up the layers in a GIS program, this is what you'd see. Some polygons with an attribute table as shown here. We're interested in the severity attribute. These are all mountain pine beetle disturbances, and the year of disturbance is identified in both the file name and the year_ attribute. To start, copy and paste as shown the whole fire layer block in the tiler.py script, lines 78 to 92 approximately. The year of disturbance now comes from an attribute. It was previously copied out of the file name for the fire layers, so just delete line 97 as shown. The next steps are a little complicated. We'll have to go back to the tiler_cheatsheet.txt file. Because we're dealing with vector layers, we'll need lines 169 to 174, which replaces the disturbance layer part of this block. We need to keep the layers.append, but replace the whole disturbance layer part. Copy and paste that from the cheat sheet. Make sure that the spacing is correct. There's 1 space too far. There should be 4 spaces everywhere. We also need to copy the substitution table example from the cheat sheet, which is going to translate our severity codes into actual disturbance types. That's the attribute part here. That's going to go where this attribute type is. Keep it clean and make sure it's all indented correctly. Go back to the layer slide just to look at the attributes. We're going to make sure that our year attribute is year_. Our disturbance type attribute is severity. You can't actually see it in the file, but it's 1, 2, and 3. Enter those on the left-hand side of our substitution table here and delete the rest. Then we need to map those severities to actual GCBM disturbance types. We have a list. Go to disturbance_types.csv in sample_data_exercise /documentation. If you scroll down to line 86, you'll find the mountain pine beetle disturbance types. Severity 1 is going to be our low impact, Severity 2 is going to be moderate impact, and Severity 3 is going to be high impact. First, we'll paste the low impact one, then we'll copy and paste the moderate impact, our number 2. Finally, we'll go back to the disturbance types and copy and paste number 3. As you may be new to the GCBM, it may seem like we're just magically finding these disturbance types, but for your own simulations you should become familiar with the disturbance types that are available in the GCBM by default. Appendix 6 of the User's Guide for the CBM CFS3, the aspatial version of the GCBM, will help you see what disturbance types are available in the default archive index database to apply in GCBM projects. Based on what disturbance type the user has, they can go through the appendix and decide which AIDB disturbance types match theirs most appropriately. This example shows how a user would use their shapefile to do this. Again, we have our year of disturbance here. The vector layer is telling our scripts what we want rasterized out of the shapefile, and then we're dealing specifically with information we need for disturbances. That's why it looks like a duplication, so severity goes down to disturbance_type. Then again, the scan_for_layers function will be used to find all of these files, so it needs to be changed from looking for fire to looking for insects. Change it to disturbances in quotes, comma, insects in quotes, comma, star.shp in quotes for all the shapefiles in there. Save the changes and close the tyler.py file. Here's a summary of the code we've just modified. The main point of this is to show that we can use different types of layers, and it's possible to do more complicated things like remapping the values in the layer to GCBM disturbance types. Once again, the user will need to clean up any TylerScript whitespace. In Notepad++, click on Search and select Replace. The Replace window will pop up. Enter \T in the Find What box, and enter a space in the Replace With box. In the Search Mode box, click on the Extended Radio button. Click on the Replace All button, save and close the file. Then we can either use process_spatial_layers.bat to check our work, or go straight to run_all.bat. Let's run process_spatial_layers.bat to make sure everything is okay. Our vector layer should actually be pointing to our layer path. This disturbance part should be layer_name, and disturbances.shp should be layer_path. If all goes well, we should see MPB mountain pine beetle layers appear. The next step is to double-click run_all.bat to run the final simulation with those disturbance layers. Once the simulation is finished, if you go into the processed_output folder, you should see an SQLite format results database as well as a folder with a series of spatial layers. This is all the spatial output from the model, including various ecosystem indicators, for example above ground biomass, total ecosystem carbon, etc. If we open up the compiled output database, you'll see all the reporting tables which include carbon stocks, fluxes, stand age, and disturbance statistics from the simulation. If we go to the stock change indicators, for example, we can see our results broken out by ecosystem indicator in the first column. We can see our classifier set, the leading species classifier, the land class, that is whether it's forest land, cropland, or some other land class, the year of simulation, the age class of the pixels, they're grouped by 20-year age classes, the area, basically the polygon, and then the carbon flux. These are meant to be user-friendly reporting tables. Unfortunately, a generic script to visualize these is not yet available. Instead, users should use whatever visualization software they are familiar with, whether it's Excel, Power BI, or graphing tools in Python. This concludes the Adapting the GCBM Template tutorial. Thanks for watching, and feel free to subscribe to the channel to be notified about new content as it becomes available.